Welcome to Maths with EJD. Now, in this series of videos, we'll be looking at some general term and importance and even applications, right, of the binomial series and its connection with power series. But I mean, in this video, the focus is first of all on the general term, which you have come across before. So we just want to emphasize how important rather this general term is. Okay. Um, the general term, the general term of the binomial expansion of the binomial expansion of a plus b raised to power n is given by tk, which is equal to n combination k, a raised to power n minus k, b raised to power k. So the general term simply means that, if you can actually jump to a particular term, right? You can jump to a particular term. So, this is not the series itself. This is just how to determine each term of that series. Okay. So, and this holds for k equals 0, 1, 2, and so on and so forth until you get to n. Okay. So this is a general term. So, and you already know that this n combination k is simply the same thing as n factorial over k factorial into n minus k factorial. And this is the binomial coefficient. This is the binomial coefficient. Okay. So that's the general term. So what is the importance of this now? For fast calculations, right? This general term can easily help you because you can if you need, for instance, if you need the 10th term, you can just use this and jump straight to that 10th term. We are going to get a good example of this, you know. But then let's talk about the importance. What's the importance of this term? Importance of the general term, What can it help us do? Okay. Now, first of all, let's look at it in the context of mathematical modeling. Mathematical modeling. So, binomial expansions, binomial expansions, model scenarios, model scenarios where combinations, where combinations of outcomes occur, combinations of outcomes actually occur, such as probability calculations. So, such as probability calculations. Okay. So that's why that general term is important. So you can use it for all these combinations that may arise in whatever you're doing. So let's look at another importance of that, talking about computational efficiency now. Computational efficiency. So we already know that binomial expansion helps us to expand whatever you have in terms of a series, right? So actually, computational efficiency simplify the computational efficiency of binomial expansion, that is, actually helps it polynomial expressions simplifies polynomial expressions for calculations for calculations in physics. In fact, we've seen some of these examples in physics, in finance, and even computer algorithms. Okay. So it's also the foundation for series analysis. Um, so it's the foundation. So it's foundation for series analysis. So, um, so this actually provides, so the general term actually helps us provide groundwork for groundwork for understanding understanding power series and their convergence. Power series and their convergence. Okay. All right. So to drive the point home, can we take some examples? Because our focus particularly now is on this general term. So with this now, you can actually do fast calculations by just jumping. So sometimes you don't need everything in an expansion. You just need a specific part of it. So let's look at some examples. So first, imagine we want to expand x plus 2 squared, or say x plus 2 cube. So if we need to expand this, right, we already know how that goes. That's like x plus 2 raised to power 3, which is the same thing as summation from k equals 0 to n of n combination k, n combination k, then x raised to power 3 minus k, then 2 raised to power k. Basically, that's how that goes. So if we go the next step, it means we have 3 combination 0, then x raised to power 3 minus 0, 2 raised to power 0, first term. Second term is 3 combination 1, then x raised to power 3 minus 1, 2 raised to power 1. Next term is 3 combination 2, x raised to power 3 minus 2, 2 raised to power 2. And lastly, we have 3 combination 3, x raised to power 3 minus 3, then 2 raised to power 3, like that. So we can tidy things up. 3, of course, just like I said in the other video, you can already know that 3 combination 0 and 3 combination 3 are the same. So they are 1 each. Then you also know that 3 combination 1 and 3 combination 2 are the same and they are 3 each. So that can actually help in our simplification. And then we move on to say that this is now, so you can say x plus 2 raised to power 3 is the same thing as 1, and then this is x raised to power 3, 2 raised to power 0 is 1. Of course, this is 3, x raised to power 2, then 2 raised to power 1 plus 3 into x raised to power 1, then 2 raised to power 2 plus 1, which we already have, x raised to power 0, and 2 raised to power 3, like that. So that means you have, okay, we can just tidy things up straight up right now. So this is 2 raised to power 0 is 1. So this is just x cubed. And next you have 2 raised to power 1 is 2 times 3, 6. So we have 6x squared plus 2 raised to power 2 is 4 times 3, 12x. Yeah, that's 12x basically. That's 12x. And then lastly, we just have 1 x raised to power 0 is 1, 2 raised to power 3 is simply 8. So that's what we end up having, x cubed plus 6x squared plus 12x plus 8. Now, this is like what we have been used to. What if I'm not interested in going all this journey? So we are talking about examples now. That's example 1. So what if if I say example 2 now, find, so how many terms are this? 1, 2, 3, 4. So I can just say third term, find the third term of x plus 2 raised to power 3. What if that is just all I want? Find the third term of x plus 2 raised to power 3. That's all I want. So in that case, all you just need to do, you just know the general term, the general term is tk, which we have before, tk, which is n combination k. All right, n combination k. What's that again? N combination k, a raised to power n minus k, b raised to power k. So a raised to power n minus k, b minus k. So if you apply it to this now, that means a is our a is x and our b is 2 and our n is 3, basically. So this is our n. So this is n now, okay? Or I mean, to make it better. So if you compare this with, so if you compare this with a plus b raised to power n, so That implies that A is X, B is 2, and N is 3. So, and what we need now is the third term. Okay, we need the third term. So, the general term. So, if you use this general term thing, now this is simply just the general term is this. So, the general term of K, I need a lot of clarity. So I can say, so the general term of x plus 2 raised by 3, x plus 2 raised by 3 is tk. All right, tk equals n, that's 3 combination k. Then a, now our a is x, right? So x raised to power n minus k, that is 3 minus k. Then b is 2 raised to power k. So we can now say as such, the third term, the third term, that is it, the third term where k is 3. So for third term now, k is 3, where k is equal to 3. Is third term where k is 3? No, 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 no. Third term is where k is 2. So if you're looking for third term, you reduce the power by 1 because you are starting from 0. So the third term where k is equal to 2 is given by T2 equal. So if you're looking for third term, you go a step before that. So that's 3 combination 2, then x raised to power 3 minus 2, then 2 raised to power 2. So this will give you the third term. So you're jumping straight to the third term. So 3 combination 2, of course, is 3 times x raised to power, that's 3 into x raised to power 1 into 2 raised to power 2. So that means you have 3 times x times 4, and that is simply 12x. Okay? So you can say, therefore, third term, the third term of the third term of x plus 2 raised to power 3 is 12x. Now, in the expansion we did before, is that correct? So term 1, 2, 3. So this is the third term, and that tallies with what we have now. So with the general term, you can jump straight to somewhere, to one place. So let me do something right now. Uh, you know, uh, okay. Let me, maybe this will be our last example in this video. Let me do an example 3 and say, find find the find the 21st term, find the 21st term of, or let me just say, coefficient, find the coefficient, find the coefficient of the 21st term of x minus 1 over x raised to power 50. Imagine. Maybe that's too large. Let me use a number that is manageable. Okay. Let me use a number that is manageable. Like, say, find the coefficient of the say 10th term of the 10th term of x minus 1 over x raised to power 20. Okay, so we want the coefficient of the 10th term of x minus 1 over x raised to power 20. So if we go straight for that, we're saying this is, of course, for x minus, well, we know already that the general term is given as n combination k. All right, then a raised to power n minus k, then b raised to power k. This is the general term. So this is the general term. So this general term can help us jump to wherever. So since we need the 10th term, right? And we are starting from 0. So the 10th term is actually going to be where k is 9. So the 10th term, the so the 10th term of okay, the 10th term, right, corresponds with k equals 9. You know, if you're going to the 10th term, so you go a step before. So, and in this case, our a is x and our b is also minus 1 over x. So don't leave the minus behind. It's very important. It's very important. So b is minus 1 over x. And of course, n here is 20. That's from the original question. So this is important. So we can say, therefore, T10, the 10th term, right? Sorry, the 10th term will be T9, all right? Because we start from 0. So the 10th term is T9. So now we have 20 combination 9, okay? Then A is x raised to power 20 minus 9. Then minus 1 over x raised to power 9 itself. So this expression, if you can evaluate it, you're going to get the coefficient. So this is now that T9 is 20 combination 9. That is okay, let me just leave it. 20 combination 9, x raised to power 20 minus 9 is 11, then minus 1 over x raised to power 9. Okay, so what is 20 combination 9? Can we quickly do that? So 20 factorial over 9 factorial, 11 factorial. All right, so this is, maybe we can even leave the answer in terms of factorial. So this is just going to be 20 times. Okay, well, I'll just leave the answer in terms of factorial. Or if I can just punch calculator for that. Okay, let me see if I can just go the calculator way. But of course, you know, this is now going to be T9 equals 20 factorial all over 9 factorial, then 20 minus 1, that's 11 factorial, x raised by 11 times minus 1 over x raised power 9, okay? So that, uh, you know, this is minus 1 over x. So the minus remains because the power is odd, right? So, but then you have now that T9 is equal to, let me see if I can quickly just get 20 combination 9, if possible. If not, I'll just leave it this way. Right, so 20 combination 9, 20 combination 9. What does that give me? Okay, I think it's, oh yeah. So that is 20 combination 9 is 167,960 times now minus x raised by 11 over x raised by 9. So T9 is equal to minus 167,960. Okay, 960 x raised power 2. Okay, so this is the 10th term. So this is the 10th term. We can also, so the 10th term, is minus 167,960 x squared. And the coefficient, and what we actually need is the coefficient from the question, and the coefficient is minus 167,960. So that's all we need. So with the general term, you can actually jump to a particular term. So you can see the number is so big, but we can still pinpoint a particular, we can actually jump straight to a point. Or you may also have a question like, go to the term where the powers of x, where there's no x, because you can see 1 over x and x can cancel out at some point. So, and of course, we can do that, but I won't do that right now. But you can already imagine that that will happen at where x is where you have x raised power 10. So it means that in that case, your k should be 10, for instance. So when k is 10, and so x raised power 10 up, x raised power 10 down, they will cancel out, and you just have a number alone. But in this case, we have found what we need to find. So still tuning. I have like so we're binomial series still continues basically. So subscribe to this channel, hit the notification bell so you can always get alerted. Comments, let me know how helpful these videos are, and let me know if there's a topic you'd like me to teach, a problem to solve. Like and share so that more people can have access to this great learning. Bye.